Hello, I'm Rod Elmore, and today we're talking about verifying trig identities. So this is a little different. I kind of think this is kind of a fun game, really. Think of it as a puzzle rather than a big problem. Like all we want to be able to do is we want to see if this side equals 1. It doesn't look like it equals 1, and we want to make sure it equals 1 for no matter what x is. If x was 30, it would equal 1. If x was 21.3 degrees, it would equal 1. So it's always going to equal 1, but it doesn't look like it, so this is sort of like reducing fractions. We're going to try to reduce this side till it turns into 1. If we can do that, then we know it'd work for every value for x. So that's what we're going to try to do. Now the best strategy here is to convert everything over to cosine and sine. Now that's already in cosine, but we'd like to convert this into sine and cosine, and this into sine and cosine, and then usually it kind of collapses or it doesn't collapse depending on whether it's an identity. Now on a test or a quiz, I'm always going to give you an identity, but the book sometimes gives you one and you're trying to verify it's an identity when it's not. In the real world, that's the way it is, but not on a test situation. So that's already in terms of cosine. So if you look at your formula sheet, and you should have some of those kind of in your mind already, the basic trig functions. We just did it last period. So what is the conversion the tangent is equal to in the sine and cosine? Well, tangent is equal to the sine of x over the cosine of x. Now, how is cosecant related to sine or cosine? Well, the cosecant we learned was the reciprocal of the sine of x. Now we just use arithmetic, so if our arithmetic's good, we can handle this. If we change this into a fraction, we could multiply all the numerators and all the denominators. That's how you multiply fractions. So let's see, on the top we would end up with cosine x times sine x. You don't really need these parentheses, but I'm kind of putting them in there to emphasis. 1 times cosine x times sine x is cosine x times sine x. And then something divided into itself is equal to 1, so 1 equals 1. And we proved that this would work for any value for x. Now the one thing you can't do here, it's not quite an equation. Sometimes an identity, just to make it more emphasis, they'll use 3 equals, but our textbook doesn't and I normally don't. But that emphasizes that this is an identity, not an equation. So you can't multiply both sides by a number. And you've got to do something on one side to make it look like the other side. That's your only choice. Because if you multiply both sides by anything, which we do in an equation, we could make something equal that really wasn't equal. So that's kind of interesting. So it's like a game to me. So let's take a look at another one and see how that might work. That was a pretty straightforward one. Sometimes they get a little trickier. And for my another example here, I'm going to go with cosine squared x over sine x plus sine x equals cosecant of x. So let's try this one and see how it works. Now we're going to make this side look like that side, or this side look like this side, but that seems a little bit tough because this is really complicated. That's fairly simple. So you really try to do this, make the complicated turn into the simple one. Now what are you going to do first? If you've got a good mathematical mind, even if you've never done one of these, the key is kind of there. Over here we see one term, and over here we see 2 terms. So it should kind of click in your mind that you would like to just add these 2 things together and see if it turns out to be what's on that side. So that's how we're going to do it. This is a fraction plus a whole number. So how do you add those? That's right, you put it over 1. And then you look for a common denominator. What would our common denominator be between sine x and 1? That's right, it's sine x. So how can you change this into a sine x? You multiply it by sine x, and therefore you multiply the numerator by sine x to keep them equal. So let's see what we get. We get cosine squared x over sine x plus sine squared x over sine x. Now if they have a common denominator, we can add their numerators together. Cosine squared x plus sine squared x all over sine x. Now we're trying to get cosecant out of this. And then some of you might recognize the numerator. What does the numerator equal? That's right, it's the Pythagorean identity that cosine squared x plus sine squared x equals 1. So we have 1 over sine x. And we could have converted this right over to sine, or we can go back, but I like to do everything into sine. So that's equal to 1 over sine x, 1 over sine x, and 1 over sine x. So we showed that this side, without multiplying both sides by anything, that this side is equivalent to that side. So this is an identity. So we've shown that that is also an identity. And these are kind of like a little game, and you can get pretty good at them. Let's take a look at one more. Let's try this one. The sine x plus cosine x equals tangent x plus 1 over secant x. I'll just think about this a minute rather than me rush into it. What can you do to make these the same? Well, this already is in terms of sine and cosine, so I just leave it. There's no way we can add these together, so we've got to leave this alone. So maybe this will work out into this. So that's our only hope. So that the tangent of x, what could we change that into? That's right. The tangent of x is sine x over cosine x. And what's the secant? It's the reciprocal of the cosine. That's why it's important that you memorize those identities. This is going to be 1 over the cosine of x. Now we have a complex fraction over here, little fractions inside of a big fraction. And algebra has taught you to do something with that. If you have a complex fraction, you should always reduce it into a normal fraction by multiplying numerator and denominator by a common denominator of all your little denominators. In this case, it's just cosine x. Now, if that seems a little strange for you, then you got to practice your algebra a little bit more, because you should have done 100 problems by now in algebra where you have a complex fraction and you do get rid of it this way. Although there's other people who might say, change this into a common denominator, add these together, flip this over and do all that. That makes no sense to me. Just in one simple operation, you can clear out all the little fractions. So now this is cosine x times this. We pick this so that this would reduce. So that'll reduce out, so that's sine x. Cosine x times 1, this is a binomial, so you got to go this times this, and this times this. That's going to be cosine x. I love these because they really reinforce your ability to handle fractions. And so I think it's really neat to see, gee, this really works, not too hard, and I'm kind of learning how to do fractions better. This cosine x would be cosine x over cosine x, but I wouldn't even do that. You pick this to make this reduce, so let's reduce it, and all you get is 1. And 1 into this is exactly what's on the other side. So to me, these are kind of little puzzles to solve, but here you had to understand how to deal with complex fractions. That other one, you had to deal how to add fractions. And that's really the only challenges in those problems. If your algebra or arithmetic is good, these should work out good. Try to make fun out of them, just make this puzzle work out. So I hope that helped. Now try the video homework and see if you can do these without looking at the video. But if you do, the key thing in having a video is you can stop it, back it up. You don't have to take notes. The notes are there. So just be thinking all the time you're watching a video, and you can always back it up. So this is verifying identities. And thank you.